Yeah, I'm Florian. I live in Oulu at the moment, but I'm not from Finland, as you might be able to tell. I'm going to speak to you about concurrency on the client side. But first, I'd like to advertise my own interest. We are organizing an event in Oulu by the end of the month, and if you're into Ruby, then you might maybe want to consider coming up. It's the same way that you come down. I know that it's much easier to come down somehow. It's going to be really nice. We got some really awesome speakers, so if you're into Ruby, you might want to check that out. In the beginning of the year, I was speaking at a conference in Poland, and in preparation for that, I came across an article that was taken out of a book called Exploring Everyday Things with Ruby and R. And basically what they did and explained in a really nice fashion was how to measure your heart rate with Ruby and R. And what they would do is snap a series of pictures, basically a short video clip, and then use Ruby to split it apart and then extract the values of the red channel, and then use R to detect the peaks in the data that they got, and then calculate the distance between the peaks and get the heart rate like that. And they explained it in such a nice fashion that I thought that's something that you should be able to do in the browser too, right? Because I got everything right here. They needed to use an external camera. They needed to use 2 languages to get this done. And I got everything in the browser that I should be able to do that too. So I started building this. And it doesn't work. It kind of works. This is as far as I got. Actually, all the code is there. You can look it up on GitHub. But the problem is the data is too noisy right now, and my algorithms, and there's a good reason that you use R and not JavaScript for this, is not capable of dealing with this properly. So you got a lot. You can see actually the heartbeats in here as well. But then you got a lot of crap over here, and you can see how the camera, well, I'm assuming that's what's going on, how the camera adjusts itself and tries to focus. So I believe you probably could make it work, and if someone wants to have a go, and my math skills are weak, so if someone wants to have a go at optimizing this, I think it should be possible, and I think it would be pretty damn cool to be able to do that. But it's this close. Go look it up, it's on GitHub. But in this context, I came across a problem, because I needed to record about 30 seconds worth of video material into memory, and I needed to process that, and it took a long time. And so I figured got to be a better way, and of course we have been dealing with web workers for a while, and JavaScript there has been a long, lengthy discussion about that, so that's what I went doing. I use web workers to process those video frames in parallel. And I encountered some problems that I usually don't have to deal with. If I work with Ruby and I work with JavaScript on the client side mostly. Concurrency is something that isn't really something I have to deal with a lot. Who of you knows what concurrency is? And who of you thinks, oh shit? Okay. Good. So I dove into this. I had some notion of what I have to do and what concurrency does for me in this kind of context. So quick overview. Really overly simplified put what concurrent code execution does. It takes a bunch of things that are being executed sequentially and executes them at the same time. In my case, I needed to do this on a whole bunch of video frames, and one of the first problems I encountered was that in some browsers, the browser would just crash. And it took me a while to realize why that is, and I'm going to come back to that. I also learned, mostly from Google actually, and not so much from my own experience, that concurrency is hard. It's just one of these hard problems, not because it's hard to implement, but it's hard to grasp and hard to sort of deal with from a logical perspective. Why? Because as nice as the graphic was, these things that you're trying to execute sequentially never take the same time. You never know how long they do take. And a nice way to explain this is the sleeping barber. Have you heard of the sleeping barber? No? Okay, great. So this is a nice way to explain the problems that exist in this context. So we're trying to find a way to explain a barber shop. We got a barber and he's sleeping. He's sitting in his chair. That's the only reason why I got this later. And a customer walks in. He finds the barber sleeping. He wakes him up and takes a seat in the chair. The barber starts cutting his hair. Another customer comes in. He finds the barber working, so he takes a seat in the waiting room. And then another customer comes in, and so forth, until the waiting room is filled up. Now, if a customer comes into the barber shop, he finds the waiting room full, and he leaves. Otherwise, every time a customer has been served, another customer comes from the waiting room and takes a seat. And so forth. This is a really nice way to explain this, right? It works pretty well. This should sort of allow us to process the customers in the barbershop pretty nicely. Except, there could be the case that the customer takes an awfully long time to make it to the waiting room, because we don't know actually how long it takes. We don't know how long it takes to do any of these things. We don't know how long it takes to cut someone's hair. We don't know how long it takes to sit down, to come from the waiting room to the barber chair. So let's say this customer had a few too many and is making his way from the entrance to the waiting room because he found the barber cutting someone's hair. In the meantime, the barber is almost done, finishes the customer, starts looking at the waiting room, no one there, goes back to sleep. Crap. That's it. That's one of like the sort of fundamental problems that are in this context existing. And you find, if you look at the more famous dining philosophers problem, you find a whole more. There's a whole bunch of problems. This is why concurrency is a hard issue. Concurrency in the browser is a completely different subject, because JavaScript is single-threaded and has dealt with concurrency in an entirely different way. Traditionally, our browsers, or in the past our browsers, would run as one process with one single JavaScript thread across tabs even. Nowadays we have either one JavaScript thread per tab, or as Chrome does it, for example, one process per tab. So these things are nicely separated and we get a lot of more power there. How does JavaScript execute code? Yeah, have you seen this type of graphic before? And why is setInterval not a good way to animate things? You have a function that is being currently executed here, foo, and at this point we are setting an interval to call a callback every 10 milliseconds. At this point, the function is still being executed. So since JavaScript is single-threaded, it's going to wait for the next possibility to execute that interval. Unfortunately, in the meantime, a click event is fired still, which also has to wait, and is being pushed right after the function execution. And then finally, a gap opens up, and we call the setInterval callback. And because we haven't yet completed the last 10 milliseconds, we actually skipped one right here. We call it right away again, and then finally we are back on schedule. If some of these things take an awful long time to execute, the situation might result in something like this. You've probably seen this all. This is because JavaScript realized, or the browser realizes, that something takes an awful lot of time to execute, but actually things are still going on. We're not blocking the UI. Well, actually, this is blocking the UI, but we are not. The execution isn't broken. The browser hasn't crashed. One of the reasons why we don't have to deal, or why this doesn't feel so bad, is that this JavaScript event model, because even though it's all executed in one thread, we still have the impression that things are happening at the same time, because an event is fired and then later taken care of, or an event handler is attached and then the event is fired later on. Real concurrency in the browser is only possible with web workers, and we noticed they have been around for a while, and we're going to bore you with a lot of details. Just quick overview. A worker exists entirely outside of the JavaScript thread, and that already solves like a lot of problems that we have in regular concurrency. They're completely separated. They don't share state. You need to communicate between those two with message passing. So you don't share state, you don't have access to the same object, you don't have access to the DOM and all of these things. There's a lot of problems already solved for you. And why this is painful? At times, it solves a lot of problems. And a work can spawn sub-threads, sub-workers. There's a bunch of different worker types existing, and I'm going to only focus on the dedicated type. Because, for example, if you look at an inline worker or these blob builder workers, the problem, in my opinion, is that the scope isn't clear. Then when you define a dedicated worker, you define it in a separate file. Everything is clear. You know I don't have access to the DOM. While if you define it in the same sort of like screen than all your other code, the scope isn't all that clear. So to come back to the heart rate measuring, one of the problems that I had to deal with was that that the browser would crash, and because too many workers would be started at the same time. That's what I found out after a while. So browsers have different kind of limits on how many workers you can run simultaneously, from 20 to 100. But I would have to process a lot more frames than that. Another issue was that I wanted to sort of keep tab on when all the frames would be done, and I also wanted to keep tab on in which order they are, so because I didn't have to reorder them at the end. So I cobbled together the build script to deal with this. That was the first version of this. And now I've rewritten this, and it's basically just a small helper that you can use to make the work with workers easier. And it's all centered around a queue. You create a job, pop it onto the queue. The queue is being worked off one after another. So you don't have to, and this happens on a global scale, so you don't have to worry about exceeding the browser's worker limit, because you can set a limit, or you can do some clever core detection and then use that limit to make sure that never more than, for example, 4 workers are being executed at the same time. How does this look? This is all in CoffeeScript. I hope that's all right. So you define a worker like this, and already here we've gotten rid of all the boilerplate that you usually have to deal with, all the post message and send message calls. You import a little API, it's a very small script, into your worker, and that gives you one call here to perform, which is going to pass you some data. You do something, and whatever is going to be returned, the job will return. You create a new job that's now happening in the main thread. You give it a job type. This will identify the worker that you have. If you remember here, the worker name that you have to find here. And then you pass on some data on. And once you are all set up, you call perform on the job. And then we have a little bit of event listening to see when the job is done, and there's a bunch more of these. That's all you have to do with this in the simplest form. There's a few events. We got a success event. That means the job has been successfully completed. We get a complete event. That means we're done. We have to otherwise find out what has happened, but we're done anyway. We get an error event. Something has gone wrong in the worker. And we get a failure event. Because we're using a queue, we can pop the job back onto the queue if something goes wrong. And the failure event is really only fired after we exceed a certain amount of tries. This might be interesting if you're having some kind of AJAX requests going on in your worker, for example, and you can't reach the endpoint. We have a little logging helper. That's also something that's always quite painful to log out of your worker. In this case, you just call log, and it will be logged to your console. And we get batches. Those are basically sets of jobs, and due to the nature of an array, they just stay sorted. So you, in whichever order you put the jobs in, that's how they come out once the batch is done. So we can we create some jobs, we push them into the batch, or we can actually push them all at once into the batch when we define the batch. And then we get events for the whole batch. We can keep track of when the whole batch of jobs is done, and the batch will also fire events for each individual job. This is nice if you need to do something like I had to do for the heart rate measuring. And again, these job events are the same that you get for the job, and since these only pass the job, you can get the last error that occurred on the job, and sorry, there's a typo here, and the end result of the data that the job has returned. There's a tiny bit of configuration that you can do. You can define how many workers will be running simultaneously. You can define how many retries, and this is exponential back-off retry. So that means that the second retry will start later than the first one, and so forth. So this is a little bit over the top for the client side, but if you have AJAX requests and can't reach the endpoint, this might actually make sense. So depending on how many retries you have, this might take up to a few seconds or even longer until the last tries is through. But since this is all happening in another thread, you don't have to worry about it if you're not depending on the result. If you, for example, only want to post some image data to the server, shove it up into the job and never worry about it again. It will try as long as it can, and in the end, if it really fails, it will let you know. There's in the future the possibility to, for example, persist these things. So I'm trying to offload some work from the server to the client, and then persist the queue. So if you, for whatever reasons, you would refresh your browser session, then the queue could pick off where it was last. But these are kind of things that you need to find out if there's any point. You can define where your workers are being stored. I mentioned the exponential backoff. Error handling, it just passes on the errors that occur, and you can rethrow them if you need. So you have them. There's a bunch of custom errors here. You can't perform the same job twice while it's running. So that means you can't perform the same job twice. You can't perform a job that is in a batch while the batch has performed the job. Just to keep track of the state of the job, and then you can get a responder not found error if the job doesn't respond to some message that the worker sends. This is sort of future-proofing this because I'm planning on implementing arbitrary message passing between the job and the worker at some point. So you could call like any method on the worker. If you want to take a look at it, you can find it here. I just started building this, and this is really just for fun for me right now, but I can I'm hoping to get to a point where basically using background jobs on the client side becomes so easy by using something like this that it's going to be done a lot more. We are assuming that every interaction or every delay more than 150 milliseconds is visible, and so everything that takes longer than that could be just pushed into a background job, and especially things where you're not depending on the result could be, or you're not immediately depending on the result, could be pushed into the background. So here are a few things that I'm planning on implementing next. I would like to have a worker shim, so you could have this. There's a bunch out there, but I would like to have something specialized for this case, that you could use it in browsers that don't support web workers. So it would just be sequentially executed, but the API wouldn't change at all. You just use it as you have it. Stronger test coverage, there are tests, but I would like to have some more. I would like to look into the serialization of the data that you're sending back and forth, if that could be optimized. But right now you can't just send whatever, you have to deal with it yourself. Some benchmarking, and then in the future I'm considering, and that's why I'm showing you this, implementing arbitrary method calls on the worker. So you could basically find a method in the worker and then trigger an event on the job, and that would forward it to the worker. But you could call the methods whatever, and perform would be just one of them. Allowing you to trigger custom events from the worker back onto in the main thread, instrumentation maybe, inline workers, I don't know. And some more helper modules that might be useful on the worker side. That's it. And if you want to find me, you can find me on Twitter and on GitHub under polarblau. Thanks.
So my question is, what is the support of this Orange? Does it support some own browser as old as Internet Explorer 8? And I would like to ask some example that you would like to run in background, but some real example, real life example.
Yeah. Okay. So first question is what's the browser support? It's the same browser support that the web workers have right now. So that's the support. If a browser supports web workers, like dedicated workers, Orange will work. There's no other magic here.
And if the browser does not support the web worker, does it fall back to some mechanism or just crash?
Yeah, that's what I meant with the worker shim that I right now know. So you could, if you want to use it, you can use one of the existing shims, but I cannot guarantee that it will work properly because I don't know how good they are.
Right.
But that's something that because I definitely see that if you want to use that, then you need to make it work everywhere. And
some real life example.
A real life example. Okay, so something that I'm working on involves you're uploading images to a service, but you can deal. So yeah, the service will then process the images in the background job on the server, cut them down and resize them and so forth, but I don't need to have the image back right away because I can use Canvas on the client side to do this until the server is done. Just next time I want to have it like a little bit faster, or maybe want to display it in different contexts where I can't use Canvas. So I could try to use the server interaction. I'm assuming you should be able to do the upload in the worker. So you just basically take a file that's a URL object and then shove it up the pipe in the background. You don't have to, because when it's done, it's done. But I'm sure there's better notifications. A user has done something. We need to let the server know about it, but we don't need to do anything in the interface right now. We can give the user right away a feedback that it's taken care of, but we shove it up the end, and should it ever fail, we tell them later. Are there any other questions? Yeah.
How do you pass efficiently large amounts of data to the workers?
That's a complex question. There is, and I'm not the right person to probably answer that, but there is possibilities that coming to the browsers now. You are now, we can look into this later a little bit if you want. I just came across this the other day. They're aware of this problem and it's being addressed. I'm not sure if there's like some binary formats coming.
Like transferable.
Okay.
You can have shared buffer between the worker.
Okay, great.
Not really shared, but you can pass the
Reference.
Yeah.
Okay. Anything else? Okay, thanks.
Was it only in Chrome, I think?
Actually, yeah. I need to point out something. In the context of this, so I mentioned error handling. If the worker throws an error, it will trigger an error event. And in the context of this, I realized that Chrome actually has a bug there. And I filed an issue with the Chrome team, but right now, if you're depending on error handling, you cannot use this in Chrome. They need to fix this, and it's actually, I think it's pretty bad bug. If you have two workers simultaneously running, I'm not sure if it depends on the same worker type, you have a pretty low chance of getting both of the errors back. Getting like sometimes one, sometimes the other, sometimes both. And that's like across all platforms and all latest Chrome versions. So actually I'm back on Firefox. Okay, thanks.